Alright, hey guys, this is Thursday, April 16th. So you'll have another quiz today. It's quiz 40. I'm not going to go back over the just dividing and multiplying. Y'all should know that by now. So dividing, remember, you just divide the numbers regularly and subtract the exponents. When you multiply the numbers regularly. But then for the variable, you add the exponents. So what I will do is do one where you have to do the factoring portion. And so that would be like this one over here they give you. And so what they're going to do, they're going to give you something and say factor it. So what you have to do is you have to find the greatest common monomial factor. So you have to figure out what's the biggest number that will go into all of them, and then what's the biggest letter with the variable that will go in both of them. And so for this one, do the number first. So I'm going to look at the 20, the 40, and the 10 and say, okay, what's the biggest number that can go into all of them? Remember, the first thing you want to do is take the smallest number and see if it'll go into the others. If it does, then that's the number you pull out. If it doesn't, then you say, okay, what number will go into it, the biggest number that will go into it and the other ones. And so notice here, the 10, I'm going to look at it because it's the smallest one and say, okay, can that go into all of them? It can. The 10 can go into 10, the 10 can go into 40, and the 10 can go into 20. And so I can pull out a 10, okay? So that's the number portion. Then I look at the variable portion and say, okay, what's the variable that can go into all of them? Well, I look and I say, this one has 6 x's, this one has 4 x's, this has 2 x's. So how many x's can go into all of them? What's the biggest number of x's that can go into each of them? That would be, of course, x squared. Because an x squared can go into an x squared, an x squared can go into an x to the 4th, and an x squared can go into the x to the 6th. And so basically the factor, the greatest common monomial factor is going to be 10x squared. And so that's what we pull out. So then we just have to figure out what goes inside. To do that, you're basically going to do the division. So I'm going to do the 20x to the 6 divided by 10x squared. And then that answer will go here. Then I'm going to do the 40x to the 4th divided by 10x squared. And that answer will go there. And then I'm going to do the 10x squared divided by 10x squared. And that will go in there. Okay? So to do this first one, 20 divided by 10 is just 10. So 20 divided by 10 is 2. And then x to the 6th, and then the x squared. You do x to the 6th 6 minus 2, because we're dividing, and so 6 minus 2 would give me x to the 4th. And so that would be the first term. So 20 divided by 10 is 2. The 6 minus 2 for the exponent gives me x to the 4th. The second term is going to be 40x to the 4th divided by 10. 40 divided by 10 is 4. And then I do x to the 4th minus 2, subtract the exponents. And so 4 minus 2 is just 2, so it would be x squared. Then the last one, 10 divided by 10 is 1. And then x squared divided by x squared would be 2 minus 2, which would be the x to the 0. Which again, anything to the 0 power is just 1. So it's really just this 1 times 1, which is just 1. And so your final answer then would be this right here. The factor form of it would be 10x squared outside with 2x to the 4th plus 4x squared plus 1 on the inside. So that'll give you a problem using the greatest common monomial factor with factoring. And so go ahead and take the quiz, quiz 40. Then when you're done with that, come back and we will do our lesson for today. Okay, so today's lesson is going to be on pages 431 moving forward. And so a couple things here, definitionally, they give you the definition of a perfect square and then the definition of a perfect cube. The definition of a perfect square is just where you have two numbers multiplied together or two variables multiplied together that are exactly the same. And so what happens here is x squared equals x times x. Because x and x are the same, you multiply them together, you get x squared. There's a 25 is a perfect square because you can take 5 and 5, the same number, multiply them together and get 25. And so since it's a perfect square, you're multiplying them together twice. You're multiplying them each together 2 times here. So see, twice. For a perfect cube, cube represents the 3, and so it has to be multiply that number by itself 3 times, or that variable by itself 3 times. And so notice x cubed could be written as x times x times x, and so that's the same letter, same variable times itself 3 times. So that would be a perfect cube. Okay, so 8 would be a perfect cube with a number, because we can take 8 and break it down, and we can get 2 times 2 times 2. And so notice 2 times 2 times 2, same number times itself 3 times, gives you 8. And so that's the definition of a perfect cube. And so those definitions are important. We're going to basically be working with those as we go through. So if you look at the next thing, it deals with a radical. And so dealing with radicals, the radical is the actual, what we consider the square root. And so whenever you have like a square root like that, this is the actual radical. The radical is that actual square root. Now, it doesn't always have to be square root. It could be a cube root. It could be a fifth root. It doesn't matter. But the radical itself is just that. Now, for the index of the radical, the index is what we can when we say square root, the index would be the square part. And so up here I did the square root of 16. The index is the square part, so it's the 2. Now for a square root, it's our base one. So typically for a square root, they're not going to write the 2 there. They're just going to write the radical in the 16, but it's the radical in the number, but it's an understood 2 if it's just the symbol. And so really the index for this one would be a 2 because it's just the symbol, and so that would tell us that it's the square root. So whatever number is here is going to be the index. Okay? Whatever number is underneath the radical, whatever number goes underneath the symbol is going to be the radicand. And so the radicand is just the number, variables, whatever stuff is underneath the radical. And so the radicand for this one would be 16. And so the radicand goes underneath the radical. The index is the number that tells you what root it is. And so for example, if I did put this a 3 and put that a 27, now the index is 3, the number right there beside that little tick mark. The index is on the outside of the radical, and then so the index is here, and then the radicand would be 27 in this case. Okay, so, and what it tells you basically, you take this, and basically is how we get this. If I took the square root of x squared, it would just be x. If I took the square root of 25, it would just be 5. So that's what we're going to get to in a second. And so it's important to understand what the index is and what the radicand is. So index on the outside, number on the outside, radicand is the number on the inside. And so to do a few problems, we'll do, I'll do number 2. This is number 2. So number 2 says, they just want you to know the base of 2. So they say the base is 2, and then they want you to know what is the square and what is the cube. And so to find the square, you just do it times itself twice. And so for the square, it would be 2 times 2, which would be 2 squared, and that would equal 4. The 2 squared would be 4. So I'll do number 4. So number 4 says a base of 4. So number 4 says a base of 4. So you're going to do 4 squared, which is really just 4 times 4, which equals 16. Okay? I'll go ahead and do number 8. So 8 gives you a base of 8. So that would be 8 for the square, it would be 8 squared, which is really just 8 times 8, which equals 64. And so the square just tells you basically how many times to multiply the number by itself. And so for 2, you multiply 2 by itself twice. For 4, you multiply 4 by itself twice. And for 8, multiply 8 by itself once there. And so that would be 64. Now I'll do the cube for these as well. So for a cube, a cube is 3, so you just do 2 cubed would be 2 times 2 times 2. So it's 2 times itself 3 times here. And so it would be 2 times 2 times 2, and that would be 8. Then for 4, you would do 4 cubed, so it would be 4 times 4 times 4. So that would be 16 times 4, which is 64. So 4 times 4 is 16. 16 times 4 equals 64. And then for 8 cubed would be 8 times 8 times 8, 3 times. And so that would be 8 times 8 is 64. 64 times 8 is 512. So you just have to do the multiplication. The key there is that square, you multiply the number times itself, and then for a cube, you multiply the number times itself, get that answer, then multiply it times the original number again. So for like a cube, you would do 4 times 4, and then multiply that answer times 4. So notice that the 4 is written 3 times, because it's 4 to the third. The 2 is written 3 times, because it's 2 to the third. The 8 is written 3 times, because it's 8 to the third. Here, the 8 squared, the 8 is written twice, because it's squared. 4 squared is written twice, because it's squared, so that's how it would work. If you had like 7 to the 5th, then you would write the 7 5 times and then do the multiplication. So that will get you through, well, I'll do like number 16. 16 says D. So if I want to know what the square of that would be, it would just be D squared. And then if I want to know what the cube of that would be, it would just be D cubed. So the variable stays the same way. D squared is really D times D, which is just D squared. D cubed would be really D times D times D, which would be D cubed. And so again, the square just tells you to multiply it times itself. And then the cube says there should be 3 of them. Then you do the multiplication. So that should take you through 16. 17 through 22. So 17 through 22, I'll do like number 18. So 18 gives you the square root of 121. So notice that for this one, they give it to you that you're just naming the index and the radicand. So the index for this one, notice that it's not written. If this isn't written, it's an understood 2. And so the index for this one would be 2. And then the radicand would be 121. So the index, the radicand. So that would be 18. If you did, I'll do 20. So 20 says the 4th root of 625. So again, the index is just the number on the outside of the radical there, inside that little tick mark. And so that is 4. And then the radicand is the number underneath the radical, which is 625. So that's all you have to do on those. So that'll get you through 22. All right, the next few says write the missing radicand or root in the blank. So they're going to give you either, you're going to have to either write the missing radicand or the some missing radicand or root. And it says make the statement true. So we're going to assume that we're making these true. So if we look at, for example, number 24, it says the square root of what equals 9. So the square root of what equals 9. And just so we got our terminology right, remember the radicand is what's underneath, the root is your actual answer, so the root in this case would be the 9. So we're saying the square root of what equals 9. So again, you have to understand how this works. Basically, whatever goes in here, you have to say, okay, what times what gives me that number? Then whatever's out here, you have to say, okay, that times itself gives me what's under here. So basically what happens is, to tell me what goes under here, I just do 9 times 9, and that would be 81. So that would tell me that 81 is going to be what goes under my radical for my radicand. And so 81 would be my answer. All right, look at like number 27. Since the square root of 121 equals what? So that now they give me the radicand and they want me to tell them what the root is. Again, this is the square root. And so for the square root of 121, what I'm doing is I'm saying what times itself gives me 121. Well, that would be 11 times 11 gives me 121. That means 11 is the root. So again, notice the relationship between the root and what's under the radical. The root is what number is multiplied twice. So 11 is multiplied twice times itself, so that's the root. The radicand is the actual multiplication of the root. So 11 times 11 is 121, that's why it's the radicand. 11 times 11, 11 is the number that's repeated, and so that is the root. So that's the relationship. Going through a couple more, look at 31. So 31 says b is the square root of what equals b to the fourth. So again, understand the relationship between the root and the radicand. So the radicand is just going to be b to the fourth times b to the fourth. Okay? So what happens, remember, is the root is what number is multiplied, is the actual thing that's multiplied by itself. So b to the fourth becomes your root because that's what we're multiplying by itself. So then to find what's under the radical, the radicand, you just actually have to do the multiplication. And so it's b to the fourth times b to the fourth. Now remember, when we're multiplying variables, we add exponents. So this is really b to the 4 plus 4, which will give me b to the 8th. So b to the 8th would be my answer that's under the radicand. Alright, now I will do I'll do 32. So 32 says the square root of k squared equals what? So again, k, now they give us the radicand and we want to find what the root is. So the root is just going to be what times itself gives me k squared. Well, how can I get k squared? What times itself gives me k squared? It would be k times k. So k times k gives me k squared, so that means the root would be k. Alright, I'll do 36. I'll give you the square root of 100 w squared. We want to know what the root is. So again, you take 100 and then you're going to take the variable and you're going to say what times what, same number, gives me 100. What's the square root of 100 in other words? And so that would be 10 times 10. And so that would give you the 10 part of your root. Remember, the root is just what number is repeated. And then for the w, it's what times what, same thing, that gives you the w squared. That would be w times w, and so that is why you plug it in there. Alright, so that is basically how it's going to go through. I'll do one with the cube root because it basically is the same thing, just with a cube instead of a square. So I'll do 51. So 51 gives you cube root 125 z cubed. Alright, so the only difference between a square root and a cube root is instead of having like 5 times 5 repeating twice, you have to have the number repeating 3 times because it's the cube. So remember, that's the only difference over here. So like here for the perfect square, it was 2 numbers. For a perfect cube, for the 3 as the index, it's 3 numbers. And so what I'm doing is, instead of doing what times what gives me 125, that's the same number, I'm going to do what times what gives me 125, that's the same number. And so that, for this case, would be 5. So 5 times 5 would be 25. 25 times 5 would be 125. So 5 times 5 times 5 will give you 125. And then the z cubed would be z times z times z. And so for your actual root, it's the number that's repeated and the letter that's repeated. And so the 5 would go here, and then the z would go there. And so that would be, our answer would be 5z. And so that should get you through today. I just need you to do 1 through 52. Finish them out, the ones I haven't done. So 1 through 52. And we'll pick it up tomorrow. So if y'all have a good day.